Hello, welcome you all guys in my YouTube channel. Please like and subscribe. Today we are going to review a research paper. Attention is all you need by Assis Bashwani, Noam, Nikki, Jacob, Elian, Aiden, Lucas. Hope I pronounced correctly. And Ilya. They are from Google Research, University of Toronto, Google Brain, respectively. First, we will look at abstract. The dominant sequence transduction model are based on complex recurrent or convolution neural network that include an encoder and decoder. The best performing model also connect the encoder and decoder through an attention mechanism. We propose a new simple network architecture, the transformer, based solely on attention mechanism, dispensing with recurrence and convolution entirely. Experiments on two machine translation tasks shows these models to be superior in quality while being more parallelizable and requiring significantly less time to train. Our model achieves 28.4 BLEU on the WMT 2014 English to German translation task, improving over the existing best result, including ensembles by over 2 BLU on the WMT 2014 English to French translation task. Our model established a new single model state of the art BLU score of 41.0 after training for 3.5 days on 8 GPU, a small fraction of the training cost of the best model from the literature. Introduction. Recurrent neural network, long short-term memory, and gated recurrent neural network in particular have been firmly established as state-of-the-art approach in sequence modeling and transduction problems such as language modeling and machine translation. Numerous efforts have since continued to push the boundaries of recurrent language model and encoder-decoder architecture. Recurrent models typically factor computing along the symbol's position of the input and output sequences, aligning the position to step in computation's time. They generate a sequence of hidden state EST is the functions of the previous hidden state ST-1 and the input for position T. This inherently sequential nature precludes parallelizations within training example, which becomes critical at longer sequence length, as memory constraints limit batching across examples. Recent work has achieved significant improvement in computational efficiency through factorization trick and conditional computations, while also improving model performance in case of the latter. The fundamental constraint of sequential computations, however, remains. Attention mechanisms have become an integral part of compelling sequence modeling and transduction model in various tasks, allowing modeling of dependency without regard to their distance in the input or output sequence. In all but a few cases, however, such attention mechanisms are used in conjunction with the recurrent neural network. In this work, we propose the transformer, a model architecture skewing recurrence and instead rely entirely on attention mechanism to draw global dependency between input and output. The transformer allows for significantly more parallelizations and can reach a new state of the art in translation quality after being trained for as little as 12 hours on 8 P100 CPUs. Background. The goal of reducing sequential computations also forms the foundation of the extended neural GPU, ByteNet, and ConvS2S, all of which use convolution neural network as basic building blocks, computing hidden representation in parallel for all input and output position. In this model, the number of operations required to relate signals from two arbitrary input or output position grows and the distance between position linearly for conv S2S and logarithmically for ByteNet. This makes it more difficult to learn dependency between distant position. In the transformer, this is reduced by a constant number of operations, albeit at the cost of reduced effective resolution due to averaging attention weight position, an effect we counteract with multi-head attention is described in section 3.2. Self-attention, sometimes called intra-attention, is an attention mechanism relating different positions of a single sequence in order to compute a representation of the sequence. Self-attention has been used successfully in variety of tasks including reading comprehension, abstractive summarization, textual entailment, and learning tasks independent sentence representation. End-to-end memory networks are based on a recurrent attention mechanism instead of sequence-aligned recurrence and have been shown to perform well on simple language question answering and language modeling tasks. To the best of our knowledge, however, the transformer is the first instruction model relying entirely on self-attention to compute representation of its input and output without using sequence-aligned RNN or convolution. In the following section, we will describe the transformer, motivate self-attention, and discuss its advantage over models such as 15, 14, and 8. Okay, thank you guys. We will read further in next slide. Thank you guys.